Good afternoon, everyone. Welcome to KP classes. So today's YouTube live is discussing the NET CSIR June 2022 paper. So we'll be discussing about the NET paper. It will be dividing the entire NET paper into three different sections: Part A, Part B, and Part 3. So we'll not be discussing discussing the aptitude part. We'll be only discussing the geology, oceanography, and planetary science and atmospheric science sections over here. So every day 2:30 p.m. we'll be conducting the NET paper discussion till the June NET examination. We'll be conducting this as a series. Like we'll be conducting the discussion of different paper. So today, as I said, June 2022 paper we'll be discussing. So as this is the first section, let's discuss few questions today. And whatever doubts you have, you can use the live chat option to interact with me. I'll be going through the chat section over here. I can see the questions that you asked. So I have my offline students also over here. So we'll have a discussion, continuous discussion with different questions. So let's start with first question. So before that, as you know, KP classes we conduct NET, CSIR, GATE, GSI, IIT JAM coachings over here. So if you want if you want online live sections, if you want offline sections, or if you just want study materials or mock tests, we have different options. Different packages are available over here. So the details to contact is given in the description box. Use the details over there. Use the link given below or the phone number. You can contact us for the more details about our coaching institute. So let's start discussing about question paper over here. So the first question. So when it comes to the question number 1. So as we know, June 22nd paper is not published in the website. So this is actually a question paper that I have downloaded from the portal of NET examination. Those who have applied the paper from there. So this is the first question. Mercury has no natural satellite because of its. So we know this is a question from, you can say, planetary science part. So what are the different subjects in NET CSIR paper? There is planetary science, atmosphere science, ocean science, and earth science questions. So when you combine oceanography and atmospheric science, almost 45% of questions are from those two subjects. Rest is from geology and geophysics. Few questions are from planetary science. So this is the first question of this paper itself is a planetary science question. Mercury has no non-natural satellite because of, these are the four options: proximity to the sun, slower orbital velocity, retrograde motion, higher temperature. Any guess? Dhruv and Udit, can you guys answer? It is because of the proximity to the sun. See, the options are given over here. Look at the option situations. So, which of the following, like Mercury has no natural satellite because of slower orbital velocity, retrograde motion, higher temperature, proximity to sun. If it has a natural, what is a natural satellite? What is moon to earth means? During the initial time, a part of earth has fallen, like it throw away from the earth, and that starts rotate around the earth. That become moon. So if something like that happen around Mercury, but that will be captured by sun, because sun is very much closer to Mercury. So hence proximity to the sun is very lower. That's why it's very proximity to sun. It is much closer to the sun. Hence, satellites or natural satellites are not possible. In Mercury, we will not be finding any natural satellite. Same goes with Venus also. There is no natural satellite for the planet Venus. Next, go to the next question. So, which one of the following basins form in collision zone? So, this is actually a tricky question. When you look at the question, it is very easy. So, when you look at the options, forearc basin, foreland basin, back arc, pull apart. Foreland, back arc, and pull apart. These are the four options. Question is which of the following basins form in collisional zone? So when it comes to, we know forearc, back arc and all these are actually associated with subduction zone. Whereas foreland basin is associated with orogeny or collision. So answer, even if it is, when you think it in a different way, like if both of them are subduction and convergence zone way, all these things are forming. But still when you look precisely, the collisional option will be this one, foreland basin. That is the one that formed because of collision. Foreland basin is always associated with an orogeny formation. So hence we have to go forward with the answer foreland basin. Now next question. A seismic phase which has undergone a single reflection. What is the answer? A seismic reflection that has undergone a single reflection. Options are PKIP, PPCP, PP and PKP. These are the four options. It is PP. So you can go over here in the different seismic shadow zones. What are each of these? Define. This is actually a very important topic for net examination. Every year they ask minimum one question from this single section. So you have to have an idea about all of these terms in detail. PKP means P wave incident on the mantle core boundary, and then it is it went into inside the mantle and then it is going again to the crust. That is PKP. So these terminologies are very important. The entire figure is very important. Okay. So those who have not revised this particular picture, you have to revise it. So this is actually, consider this section as to understand what are the topics that you have to revise before the net examination. So if anybody have not revised this section, please go revise with this image and what are each terminologies defined. Now next question. Which one of the following ore deposit is typically formed in magmatic segregation process? So we have reached the exploration geology part. This topic comes under exploration geology. So which among the four options uh, formed by magmatic segregation process? Porphyry copper, bauxite, chromite, phosphorite, chromite. So this is actually a very easy thing. but again very important part. All the different types of ore formation processes are very important. You have to revise that. What is magmatic segregation and its example, dissemination, what is magma injection, all the different process of formation of ores and their examples. Also, you have to study about like what is Suginda chromagma, like what particular kind of formation has happened over there. That is also very important. Which one of the following places exposes fish type of sedimentary sequence? So for this you should remember, understand what is fish. Fish type of sedimentary sequence. There are two terminologies, fish and molasses. Both of them deposit in one associated with marine environment. Terminology of fish and molasses. Here they have asked about fish. Molasses terminology is also very important. Fish deposit in the deep water environment. Molasses deposit in the shallow water environment. So we get fish and molasses deposits associated with forearm basin, backyard basin. There also we get fish or molasses deposits. So when it comes to orogeny related part, like from orogeny erosion happen and deposition happen in the deep marine environment, and fish can form both sediment, both sandstone and or siltstone or sandstone along with shale will be there. That is the major components of fish. So you can see the option made answer is Port Blair. Port Blair is in the Andaman Nicobar part. So there we get the fish deposit. So because that will be a deep marine environment. In among these all options, where are the chances of getting a deep marine environment deposit? That's what you have to look at. So you should have an idea about the geography part also, and what you should know what is fish and its composition, how they are formed. Now choose the correct statement. This is an important topic. Four options are given, and all four options are about Rossby waves. So first of all, what is a Rossby wave? Which is very important to understand. Whenever we define a Rossby wave, we learned about jet streams in our class. So here we know where are jet streams forming. So and we also discussed about the meandering of jet streams. They do have meanders, and because this meandering of jet stream is what is called as Rossby waves. Rossby waves, in an easy way of explanation, is meandering of atmosphere jet streams when they become more like wavy, and that situation are called as Rossby waves. Okay, atmospheric Rossby waves. There is ocean Rossby wave are also there. Oceanic Rossby waves we get in the when we study about the different layers of ocean. Surface mixed water, then we have the thermocline layer and the deep water. In the thermocline actually mixing happens, so the temperature variation happens in the thermocline layer. So in that thermocline layer, water movement is taking place along the thermocline part. That is what is called as oceanic Rossby wave, and that actually moves towards the westward direction. But we know jet streams move towards the east direction. Hence, atmospheric Rossby waves, they move towards the eastward direction. Okay, so when they swing, so we can see over here, because of meandering, some amount of like it come towards the equatorial region. From equatorial region to polar region it move. Again it is swinging towards the equatorial region. Equatorial regions to polar region it swings back. So when they swing towards the equatorial region, it brings the air coming will be colder, and when it go back towards the polar region, air become warmer. So these Rossby waves have a very important role in balancing the temperature between the polar region and between the tropical part or between the towards the equatorial region. Then the next important thing is a small change in the Rossby waves. A small anomaly in the Rossby waves can cause, for example, these molecules that are moving, suddenly they stop. Their velocity decreases. They become static. That situation can create a huge amount of climatic variations on the Earth's surface. There is huge storm activities or forest fires. All these things have taken place because of the anomalies happened in the Rossby waves. So Rossby waves, they always move in the eastward direction. Then they interact with, there are different more detailed part is there about the Rossby waves. More detailed section is there. So understand they are a part of jet stream, or they are the meandering of jet stream. This meandering, when the temperature contrast is maximum, jet streams form in the front. Remember, jet streams form in the, there is polar jet stream also, subtropical jet stream also. At the front we get the jet stream. So when the temperature contrast on the either side of the front is much higher, at that particular, it is when it is maximum, jet stream flows in the almost near straight pattern. Other situations when the temperature contrast become minimum, jet streams start moving in the meandering pattern. So during that situation, when temperature contrast reduces, jet streams start to follow a meandering path, and hence the meandering path depends upon the temperature contrast. So temperature gradient. So this meander, it can be a ridge or it can be a trough. Okay. So towards the pole, we call it as ridge. Towards the equatorial region, these are the trough. So these troughs are the low pressure zones. Remember all these things we have discussed already in the class. The troughs are the low pressure zone and the ridges are the high pressure zone. High pressure zone. So these meandering jet streams are called as Rossby waves. So this is a very natural phenomena. There is nothing different. But when, so as I said, temperature contrast. So with the effect of anthropological changes or a small change in the atmospheric temperature will affect these kind of circulations very drastically. Hence, a huge climatic changes, localized flood, localized forest fire. So in Russia, there was a forest fire almost at the same time. Pakistan was completely submerged under a huge drastic flood condition. So one side it is flood, other part it is huge forest fire. Both of this phenomenon was because of a Rossby wave anomaly. So a small change can cause global wise, same as El Nino, a global wise change in climatic patterns can happen because of the Rossby wave. Okay, and hence this also planetary in planetary atmospheres, because of Coriolis variations, the direction changes and everything, jet streams variation happen. When the contrast of temperature is low, jet stream speed will also become low. Coriolis force is weak and become weaker. We learned that maximum speed, maximum curvature the air molecules take because of Coriolis force. So if temperature contrast is lesser, that means jet speed decreases. Then the Coriolis effect will also be lesser, and that is what is leading to the meandering force. Why it is taking this straight path? Geostrophic wind. Remember, geostrophic wind is what causes the straight path of jet stream. Geostrophic wind is the balance between pressure gradient and Coriolis force. If temperature contrast is weaker, speed of jet stream become weaker. When the speed reduces, that will weaken the Coriolis effect. Hence, it undergo meandering. Clear? So this is the existence of waves explain the low pressure cells, high pressure cells, etc. are because of these meandering curves actually. And the entire setup of Rossby waves, if there is a mountain, for example, if this is above the Indian Asian continent, we have Himalayas and all the mountains have present over there. So because of a mountain, this localized change in the patterns of Rossby wave can happen. So that particular area we call it as waves are called as forced waves. When there is mountain or temperature difference is there across the globe, temperature difference between ocean and continent, if there is a localized or a temperature contrast because of globe and ocean is continents and ocean is there, and or there is mountains to interrupt the jet stream exist, because of that a wave created is what is called as forced wave. In the same way, use a different color. Then there is another term called as synoptic waves. These are actually, we can say the Rossby wave consists of two different parts. Synoptic waves are the normal, it moves very quickly on the atmosphere. That situation is synoptic wave. And whenever there is a mountain region is there, movement it will be changing, big changes on the movement happen, and that situation is forced wave. Or at the contrast between a continent and an ocean, but there is a huge temperature variation is also there. So that can also give rise to a forced wave. Okay, this much is not required. Mainly they ask about direction. So this here question is, now go back to question. So this is clear. So the major cause is cost of Rossby waves are meanders of jet stream. They form because jet stream becomes weakened. Why jet stream become weakened? Why it become weak? Because of the reduction in the temperature contrast. And if jet streams become weaker or speed reduces, then the Coriolis effect will also become weaker. When the Coriolis effect become weaker, it causes meandering. And the trough is what the meandering part towards the equatorial region, that is trough. The one that is towards the polar region is the ridge. Ridge part is the high pressure zone, troughs are the low pressure zone. So this meanders is what is called as meandering waves are called as Rossby wave. So now the question. See, they have written very elaborate, very lengthy questions and options, everything. If you read it very carefully, you'll get the answer. Low frequency Rossby waves, they say thus Rossby waves associated with equatorial part or more towards the tropical region. Those are actually low frequency Rossby waves means equatorial Rossby waves. So Rossby waves propagate westward in the northern hemisphere. Low frequency Rossby waves propagate eastward in the northern hemisphere. Low frequency Rossby waves propagate eastward in the southern hemisphere. Low frequency Rossby waves propagate eastward along the equator. This is the question. Which one is the correct statement? Okay, option. They have asked the correct statement. You guys see, low frequency Rossby waves propagate westward in the northern hemisphere. Low frequency Rossby waves propagate eastward in the northern hemisphere. Low frequency Rossby waves propagate eastward in the southern hemisphere. Low frequency Rossby waves propagate eastward along the equator. Huh? So whenever they ask the question, always consider oceanic Rossby waves move westward, atmospheric Rossby waves moves eastward. Okay, so, and this is what is associated with the northern hemisphere situation because it is affected by Coriolis force. In the southern hemisphere, the direction will be different. Oceanic one are the one movement is along the thermocline and movement is towards the westward direction. When it comes to the atmospheric one, they are high altitude situations and everything. All the terminologies are associated with jet streams. High altitude, very high velocity, everything is there. The direction is towards eastward in the northern hemisphere. So the answer is actually, we can say, this is the actually answer that is coming. So this is also, paper is also kind of like, we can say similar to GSI paper. Options, all the four options feels like right one. You have to choose for the best fit option. Okay, the same thing goes to the basins they just mentioned, the collision basin. All those, if you think in one way, everything is associated with the collision situation. Ocean continent collision, yeah, ocean or continent collision. But when you specifically say collision is associated with orogeny, and orogeny comes with foreland base. So that's how we have to think and give an answer. And if it is confusing, don't, we have enough of options left. If the question is confusing, you can leave that for the further, like if time left, you can come back and think about it. Otherwise, don't. If it is confused, don't try to give answer. Especially net paper, because we have options over there. Now, radiocarbon activity in a sample is found to be 1 by 4 of the initial activity. If the half-life of the radiocarbon is 5700 years, then the age of the sample is dash. This is the question. So actually there is a direct equation for this particular terminology. Direct equation is there. Anybody equation associated with this? What is the term activity means? Activity means, okay, we will study geochemistry in our sections, but though with this net examination is going to happen, so we have to revise. Activity means it is the decay per second. That is called as activity. We use the unit becquerel also. Sometimes we simply use the term decay per second. In that way itself we mention. There is, they have mentioned the initial activity of carbon as carbon. See, radioactive activity in the sample is found to be 1 by 4 of the initial activity. So if I 14 right over. So when it comes to the 14 carbon is the initial activity and 14 carbon T at right now. So see, T means present time, 0 is the initial activity. Okay. So 14 carbon initial activity, whatever 14 carbon initially was there or activity was there, only 1 by 4 is present now. 14 carbons 1 by 4 activity is what is now present. This is clear. Okay. Now I'll write it in one corner. So 14 carbon activity at time T is equal to for 1 by 4 of 14 carbons activity at initial time 0. This is given in the question, and they have already given T half is equal to 5700 years. This is also given. They have asked us to calculate the age of the sample. T is what you have to calculate. Age is what we have to calculate. Now over here, when we have to define the age situation, there is a direct equation. I'll give you the direct equation. So first you should know how we have reached over there. So when it comes to the equation, you might have seen this particular equation. We commonly use this n naught by n nt is equal to n naught into e raised to minus lambda t. Nt is equal to n naught into e raised to minus lambda t. This is the basic equation. So nt is carbon at time t, n naught is carbon at initial situation, and lambda is the decay constant. We know the relationship between t half and lambda. Lambda is equal to 0.693 divided by T half. Half life will get the lambda. So if I rearrange this equation, I'll get T, and when I come up with, so this initial n naught value is actually known for us, like for carbon, initial activity is a constant. We know that value. So if I include all those things together, the equation is, you better remember this equation, T is equal to 1.209 1.209 into 10 raised to minus 4 per, sorry, 1 4, this is the T half. This is the lambda value, sorry, 19.035 into 10 raised to 3 logarithm of n naught by n. This is the equation. If I rearrange the previous equation by putting the lambda value or T half value and changing the exponential e raised to lambda t into logarithmic term. First we have to convert that into natural logarithm ln, then ln to log. So then the equation will be this. Age is equal to 19.035 into 10 raised to 3 of log n naught by n. Now this situation n naught by n is 1 by 4. It is 4, 1 by 4, it is 4, n by n naught is 1 by 4. Huh? That's clear. It's given in the question paper, this from this particular statement. 14 carbon at time t is equal to 1 by 4th of carbon initially. So initial carbon divided by C t at time t is equal to 4. So if instead of log 4, I'll write 19.035 into 10 raised to 3 of log 4. We'll get the direct answer. Simply do the simple maths. We'll get the answer. So this almost comes something as 1133 or something. This much years. Yes. This is so. Remember this equation because even in GATE they ask similar questions. So NET also they repeatedly asked about carbon. Carbon 14 is one of the very important radioactive isotope that you have to study. That you have to remember the equation with. Because all other elements, all other radioactive elements equations are the same. This n naught equal to n into e raised to, that equation only you have to remember. They will give you the lambda value, they will give you the t value. But for carbon 14, better to remember this equation itself. So the option is this one, 11,400 years. Option C is the right answer. So numerical questions are also very important to study or to keep in mind. Okay. Next question is this one. Which one of the following periods is known as age of fishes? Very easy. Devonian is the answer. Geological time scale you have to go through once before the exam. Age of fishes, age of mammals, age of reptiles, age of amphibians, all those terminologies you have to go through. Then you have to see the major, like where was the red bed started forming on banded iron formation, or the major terminologies associated with the geological time scale that you have to revise before the examination. And in the geochemistry question where you have to revise the equations also once. All the geotectonic, geochemistry related equations, radioactive isotope related equations. And another thing is the decay scheme. Alpha decay, beta decay, gamma decay, all these decays in detail. Like alpha decay, mein, what is the change happening in the parent to daughter? What is the change between parent and daughter atomic number, mass number in beta decay? And where is X-ray emission happens, in which particular decay X-ray emission happens. These kind of details are very important. So those things you have to revise before the examination. Then comes the geological time scale. Sometimes they ask among the option which one is the duration is most for which one, least duration is for which one. Kind of very basic questions they ask from. time scale. Not very hard actually. Next question. Seawater sample, bicarbonate, carbonate of seawater sample are 1.8 and 0.25 mm respectively. What is the carbonate alkalinity of this sample? They have given the values of bicarbonate 1.8, carbonate 0.25. They have asked us to calculate the carbonate alkalinity. There are so many equations for carbonate alkalinity. Basic thing that you have to keep in mind whenever they ask alkalinity is bicarbonate plus bicarbonate plus 2 carbonate. This is the basic equation that you have to know. So here they have bicarbonate is 1.8, carbonate is 2 into 0.5. This will be the answer. You don't even require a calculator. You can do it in your mind. It's 2.3. Yeah, this will be the answer. Okay, so alkalinity equation, keep in mind. Alkalinity is summation of bicarbonate plus 2 carbonate. This is not a very common kind of question. Epicenter of a deep focus earthquake is normally located at the depth of dash. Huh? Yes. Now, this is the common mistake everybody make. Read the question once more. What are they asking? Are they asking about focus? They are asking about. Hi Nirvan, you are watching the video now. Please give the answer for these questions. We are discussing June 2022 paper. Epicenter of deep focus earthquake. If it is earthquake, we are dividing earthquake into shallow earthquake, intermediate part, then comes the deep. This is on the basis of focus. Shallow focus earthquake means 0 to 70. And 0 to 70 kilometer depth. That is shallow focus. Intermediate is between 70 to 300 kilometer. Intermediate focus means 70 to 300 kilometer. Deep focus means 300 to 700. All these are right. Everything is correct. But the importance is that they were actually asking about not the focus, they are asking about the epicenter. If it is deep focus, if it is shallow focus, intermediate focus, epicenter is at the depth of 0. Understood? So always read the question properly before giving the option. And net examination, if it is it's online, so it's easier for to remember actually. Epicenter of deep epicenter of deep focus earthquake. That is the question. Epicenter of deep focus earthquake. Okay, so option D is the right answer. Is 0. I hope everybody understood. Yes, Kushi, it's 0. Sai, 0. Next is Identify the incorrect pair. Solute load, incorrect pair you have to identify. Solute load to dissolved load, wet load to traction load, suspended load to wash load, traction load to solute load. Which is the answer? Incorrect pair. So this is about the geomorphology portion where we discuss in the fluvial system. There are different types of ways to transport sediments. So when it comes to the transportation, sometimes sediment transport as dissolved load or traction load, wash load, solute load, etc. So dissolved load means the one that is soluble. So solute loads are dissolved load. That is correct. That terminology is actually correct. Next, next one is bed load to traction load. When it comes to the bed load to traction load, bed load is the one that is undergoing traction movement, right? Bed load is undergoing traction. So that is also correct statement. Next is suspended load to wash load. Suspended load is the one that is wash load. They wash out. Suspended load matlab they are not soluble but they are small clay size or sill size particle which required a very low velocity to settle down. Those are the suspended load. They only settle down when the velocity, when the energy situation is least. Then only settlement of suspended load happens. Then the last option is traction load and solute load. Traction loads are not solute load. Option D is the incorrect statement or incorrect option is option D. Incorrect pair is option D. Traction load means the movement of particles, mainly the bed load. How bed loads are transported, that's what we call as traction load. Bed loads will be transported through the bottom of the river channel. So along the bottom the movement happens. So solute load will not be transported as a traction load, hence the option. This is the incorrect pair. So over here this is the correct answer. Which one of the following is ultimate limiting nutrient for ocean productivity? So we learned about ocean productivity yesterday. So there we saw the different types of nutrients like nitrogen, phosphorus, silica and iron. These are the major nutrients that can limit the productivity, or productivity mainly depends upon these particles. So when it comes to the productivity related terminology, there is a statement defining this particular term. So when it comes to the ultimate limiting nutrient on the geological time scale. So for a nutrient as nitrogen and phosphorus, it's not silicate and iron actually. Major ones are nitrate and phosphate. Among these two, nitrate is actually proximate. Matlab, they they can affect the productivity in a smaller duration. When we think about a geological time scale for a huge time duration, nitrate cannot be a limiting nutrient. That is actually phosphate. So phosphate is a limiting nutrient even in a larger duration actually. So this one is better to keep in mind, this statement of nutrients, the terminology related to nutrient, which is very important. Phosphate is actually the ultimate limiting nutrient on a geological time scale, whereas nitrate are not. Nitrate, we don't need to think about the other nutrients because others are not very well defined. So here there are two terminologies. Proximate limiting nutrient, proximate limiting nutrient and ultimate limiting nutrient. These are the two terminologies. Proximate limiting nutrient and ultimate limiting nutrient. Proximate limiting nutrient means these are the one that is locally or temporarily limiting the primary productivity. Photosynthetic productivity is being limited in a temporary basis or locally, and that is what is the nitrates are the example. Nitrogen is the example for that. Then next one is ultimate limiting nutrient. It determines the productivity for a longer duration. So on a geological time scale, phosphate is thought to be the ultimate limiting nutrient of ocean productivity, and nitrogen is thought to be limiting only the proximate sense. Okay. So if the time scale is to years, like hundreds of years, maximum years to centuries, then the productivity limiting part will be nitrogen. If it is for millions of years, productivity limiting factor will become ultimate limiting nutrient, that is the phosphorus. Now, downward bending of isotherm is commonly observed in which of the tectonic setting? Options of downward bending of isotherm. Subduction zone, volcanic arc environment, craton interior, divergent plate boundary. Four options. Subduction zone, volcanic arc environment, craton interior, divergent plate boundary. So this is the second question from geotectonics after we discuss it. After we start discussing, or in this particular paper, this is the second or third question from geotectonics. So you can understand how important is geotectonics, and they are still asking about the plate tectonics part. Bit before they asked about the same for land basic plate tectonics part. Here also they are asking about the plate tectonics part, about the isotherm. So this is a very easy question. If you have ever seen a subduction zone associated, a subduction zone isotherm, see, this is the subduction zone. You can see the downward bending isotherms in the, what is isotherm? Isotherms are the lines that connects the same temperature. So it always have a downward bending isotherm. If it is an orogenic collision or continental collision, that is orogenic formation, will never be this term. The isotherm will be in such a way that temperature gradient increases with increase in the depth. Here there is a downward bending because of the subduction that is happening. Actually, this was a very easy question. Few people got confused and they could not answer that by looking at other options. Craton interior means there is no much change in the gradient will be very, the average gradient only they follow. With depth, temperature increases. Next, which of the following indicates that the mantle is solid? Which one indicates mantle is solid? Yes, Kushi, it is subduction. Kushi, it is not iron. It is phosphorus and nitrogen are the major nutrients when we study about the productivity. So we have to think about whether it is nitrogen or phosphorus. Nitrogen can only limit the productivity for few years or century we take. It can, the nitrogen can limit the productivity. But when it comes to the millions of years, geological time scale, that means 4,000 billion years ago to till now. So in this situation, where billions of years ago, we take that much higher duration, there the limiting factor become phosphorus. So now this question over here, mantle, convection, phase transformation, propagation of S wave, subduction of a slab to a depth of 600 km. Among these four options, which one we can use to define or indicates that mantle is solid? Huh? S wave, propagation of S wave. S wave, when it reaches the mantle core boundary, it becomes It won't be able to transform as an S wave. The energy will be transferred when it comes to the inner core. Then again S wave will be appearing. So this is the second time we get to see a question related to seismic wave. Earthquakes, this is the third question. If you think in that way, earthquake is also a very important portion for net paper. This is the third time they are asking question from earthquake section, seismic wave. So propagation of S wave is very important. S wave, this difference between the S wave, P wave, Rayleigh wave and love wave we have to keep in mind. P wave is the primary wave, S wave is the secondary wave. Which one is transgressive movement, which one is longitudinal type of wave. The equation for velocity of P wave and its relationship with bulk modulus, and there is rigidity modulus also comes in P wave, whereas in S wave there is only mu by density, rigidity divided by density, that is what defines the S wave velocity. It doesn't have bulk modulus terminology over there. So S wave cannot travel through liquid, it can only travel through solid. So you have to study detail about all the different types of relationship between P wave, S wave to rigidity modulus and bulk modulus. The velocity of P wave and S wave are controlled by density. It depends upon density, it depends upon the rigidity modulus and bulk modulus. Then comes the Rayleigh wave and love wave, the surface waves, and their peculiarity, their movement. One is perpendicular to the direction of propagation. Both are perpendicular to the direction of propagation. The movement is perpendicular to the direction of propagation. So those terminologies are very important. Keep in mind. Next one is, which planet has the highest orbital angular momentum? Which among these options, which one has highest angular momentum or orbital angular momentum? Angular momentum. Any guess? The guys, this one answer. Angular momentum L is equal to 2 pi m r square divided by p, where is m is the mass, r is the radius, and p is the linear velocity. This is the equation. Now tell me which one will be the answer. Earth, Mars, Saturn and Jupiter. Which one has the highest mass over here? Jupiter. Radius. Saturn has radius ज़्यादा. Which one is the biggest planet? तो radius किसका ज़्यादा होगा? Okay. So answer is actually Jupiter. When you calculate the value, Jupiter's angular momentum is 6.9 into 10 raised to 38. Earth का momentum is 7.1 into 10 raised to 33. 10 raised to 33. 7.1 into 10 raised to 33 is the angular momentum of Earth. That of angular momentum of Jupiter is 6.9 into 10 raised to 38. Okay, so angular momentum, keep in mind. Angular momentum of solar system. When it comes to Earth, angular momentum is 1 into 10 raised to 42. That is angular momentum. Yes, Sai, Kushi and Sainul answer is Jupiter. So the next question. The decrease in P wave velocity from 13.6 km to 8.1 km per second is known to be represented by which of the following discontinuity? P wave velocity is changing from, so this is how geotectonic part, earthquake part, question. See how important is that particular subject. P wave velocity is from 13.6 km per second to 8.1 km per second. Huge decrease in the P wave velocity is happening at Repeti, Lehman, which discontinuity, Gutenberg and Conrad. These are the four options. Gutenberg, that is the discontinuity between mantle and inner core. So where solid to liquid transition happens, velocity changes from 13.6 km per second to 8.1 km per second. P wave velocity variation. Velocity of S wave becomes 0. How is the concentration of dissolved organic matter comparable to particulate organic matter in the open ocean surface, ocean. Particulate organic matter and dissolved organic matter. Particulate organic matter means, particulate matter means the one that is not dissolved. It has usually have a diameter of 0.53 to 2 millimeter, small particles, particulate matter. Then comes the dissolved matter. Dissolved matter is soluble material. So in the surface ocean, between dissolved organic matter and the particulate organic matter, 90% of the total organic compound is actually in the form of dissolved organic compound. 90% of total organic carbon in ocean is dissolved form. Dissolved organic matter. 90% of carbon in the ocean water. So when you compare, and it's about 100 to 500 micromolecules of carbon per kilogram of seawater. 100 to 500 micromoles of carbon is present in 1 kg of seawater. 100 to 500 micromoles. So here answer is actually this one. It is 10 times more than the particulate carbon or particulate organic carbon particle when you compare with this one, dissolved organic carbon. Okay. So this also write down the statement because I have not mentioned in the class. This one. Now, how does the depth of the ocean relate with the depth of the edge of the ocean floor? How does the depth of the ocean relate to the edge of the ocean floor? This is also a question from geotectonics. That is actually a small. Yes, Kushi and Sai, it is Gutenberg. Can you answer this question? Which of the following option, like how does the depth of the ocean relate to the age of the ocean floor? It increases with age, it decreases with age, it is independent of age, it decreases until 55 million years. Remember, see, this is how we connect with some topics that we have learned, and I may not have told this statement in the class. But remember, I have told you that at the site of mid-oceanic ridges, when the new oceanic crust develop, so this may be at a depth like much above than the calcium compensation depth. So carbonate deposition can happen over here. So when further spreading happen, this one will come to the deeper ocean. So here, when it comes to the deeper ocean situation, it will be surrounded by this. Anyway, that is the final question. So what will happen at the mid-oceanic ridge situation? Here, when it is above the calcium compensation depth, carbonates can deposit, and if suspended load deposition happen or silica deposition happen above the carbonate deposit, this is carbonate CSO3, and this is the SiO2 deposit later happen. Now, because of spreading, this calcium compensation calcite deposited below the silica will reach a deep marine environment. So this is CaCO3 and this is the SiO2. So this is one of the case where calcium carbonate deposition is found below the CCD, calcium compensation depth, in this particular case. So hence, where what will happen with increase in the depth, whether the age increase, oceanic crust, obviously in the shallow water countries, with oceanic ridge and everything is shallow situation. So with increase in the depth, the oceanic crust over here is younger and oceanic crust over here is the oldest. So with increase in the depth situation, the age should increase. Okay. So this much is what we have discussed for today. Tomorrow we'll be discussing the rest of this part. Will be discussed tomorrow again. June 2020 paper will be discussed again. So thank you so much for attending the section. So those who are my students, please revise the topics that we have learned. Everybody please revise the topics that we have learned. So geotectonics is very important topic. We just maximum 15 questions we have discussed today. In the 15 questions, 3-4 questions are from a single topic. So it's a very important topic. Revise. So while today itself you can revise the topics that we have discussed over here from this particular question paper. Geological time scale, P wave, S wave related terminologies, plate tectonics related portions, these things, so you can revise and keep it in mind. So tomorrow again we'll discuss the rest of the questions. We'll meet again. If you have any inquiry about KPK classes for the admission or for the demo class, for mock test, anything, you can contact the details given in the description box. Will help you out in any manner. Any doubts you have with related to geology exams, will help you out in that. So thank you so much. Let's meet tomorrow by 2:30, the next live section.